Welcome back. This is Professor Robert Needing, and today in working with Desmos, I'm going to be plotting data for scatter plots. In addition to just simply plotting some data, we're going to create an XY list. We're going to do that from grabbing a copy paste and creating our own. We're also going to convert some multiple XYs in order to lists. Look at them in an X1, Y1 situation. We're going to do a little bit of regression, and we are going to plot the residuals. Inside that regression, we'll be able to get the B value, the M value, and the R value, which is going to be important to you in Math 168. So let's take a look at just some basic stuff in lists. So first of all, I'll save my graph as I always do, and we'll call this one maybe regression in Desmos. It was important to save your data so that you have it. Remember, if you want to get back to old data you've done in the past, you just hit the three little lines here, the menu, and the menu will take you back in any saved graphs that you have. It'll also give you a lot of examples that you can grab too, if you want to look around. Close it up, you just hit the simple three-line menu again. In order to make anything graphable. So for instance, let's just make a point. Let's just make a point 2, 4. 4 pops up right away over here on my graph. I can see it right there. Remember, I can move my graph around and just simply grab it and go over it. If you want to label it, you can label it. You can also change your settings. If you haven't changed your settings already, if you put it into projector mode, notice it stands out a little bit bolder kind of thing. You can change how big your axes are and what you count by right here if you want to. You can add a label to the y-axis. You can call it something, you could call it years. And oops, can't spell years, can I? If you call it something years, then we can actually get a label that pops up on the x-axis itself. We can step by different values. Right now, I don't want to. And I actually don't want to label either. So when I make these lists, I'm not limited to just a simple list of one data point. So I can make another data point. So let's say 3, 7. Again, if I want to label that list, I can label that list. And I forgot to put a comma here. Notice 3.7 didn't work because I used a dot instead of a comma. And again, if I want to label both of those lists, I can do that. If I want to change the dot, I can change the dot by holding. Click and hold, and I can change the style of the dot. If I want X's on these instead of having values of circles on these, I can change the color if I need to. If I want to hide these dots, I just simply click on them one time. Rather than deleting them, I can just simply hide them. In addition to that, I can build a folder. And sometimes I want to build a folder that says, these are my dots. Now notice that my folder doesn't contain anything. If I collapse it and expand it, nothing happens. But if I open it up and I take these values and I drag them just underneath, and I'll take this one, I'll drag it just underneath. Notice when I collapse the folder, they're inside of there. Well, what does that do for me? Well, if I hide the folder instead, all the parts in the folder go away, which is kind of nice because then I can collapse it, get it out of the way, and I can come on to a new project, do something different. So let's say that I'd like to make several dots, but I don't want to make a whole bunch of different lines. All right, well, we can do that too. So let's say we can go 2, 1, comma. Let's go 2, 3, comma. And let's go 2, 4. Oops. And I keep hitting my wrong value there because you can see I got a decimal sitting right there. 2, 2, 2, 2. And oops, got myself finished here. It says the points are written like this, blank, 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 blank. I forgot, if you look right here, and see, it tells you, it's pretty intuitive that it tells you if you make a mistake, a typing mistake. And if you click that little warning sign that I had right there, it'll tell you that. And there's my 3 dots right there. Not bad. Okay. What if I want to go grab some data somewhere and I want to paste it in as a set of X's and Y's, which is normally probably what we'll wind up doing. So let's go find some data. How about, last time we used hot dog data. How about we use cricket chirps? That's a pretty good piece of data right there. Cricket chirp. So again, I click the CSV. You could click any of the, you could click the TXT if you want to. That'd be fine. Open up the CSV. And now we're going to want everything here. We're going to want the headings. We're going to want all of the numbers. We're going to want to control, copy all of this stuff right here. And then what we're going to do is we're going to go back into Desmos. And in Desmos right here, we're just simply going to click in one of these and we're going to control V. Control V, you'll notice it automatically populates X1 and Y1. And she makes the data change to X1, Y1, and it plots all of the corresponding data. This is my data. If you want a nice looking graph of where you should be with this, there's a little magnifying glass right here. Hit that magnifying glass and it will make the best optimization for you. So I now have X1 and Y1. I'm going to get rid of these here. I'm going to make those go away. I don't need those. And I'm also going to get rid of these dots here. Just going to work with this piece right here. So what am I going to do here? Okay. Well, now that I have this, what I want to do is I want to see if I could have a line of best fit. Now, remember what a line of best fit is. It's me trying to make something, for instance, y equals, I don't know, let's say 2x, and that's not bad, huh? Y equals 2x, and I'm trying to make this line move around in such a point that the residuals or the dots are as close as possible to the line. We want the distance from these lines to be minimized, from these points to these lines to be minimal. And clearly this could stand up a little bit. Maybe it could go up to 2.1. That maybe wasn't what I wanted. Maybe I want to change a little bit. Maybe I want to go back to 2.0, but I want to drop it down a little bit. So maybe I want to go minus 0.1 or maybe further minus 0.5. I don't know. But the calculator will actually do this for us, and it'll do a nice job of taking care of this. So here's what we're going to do. We're going to do what's called regression. And we're going to regress and tell the calculator, I want you to look at the data you see, and I want you to find the very best fitting line that's appropriate for this. And the way we do that in Stacky, in Desmos, is we have to first tell it the normal of y equals mx plus b. Because that's how Desmos works. Desmos works in such a fashion that it's going to put the value of m first, the slope. It's going to put the value of b next. In stats class, we talk y equals a plus bx. What we discuss when we're in stats class, and it's really the same exact formula. The only difference here is the m is attached to the x here, and the m over here is the b. Over here, the y-intercept is the b value, but over here, the y-intercept is the a value. What I really usually tell my students to look for is the two letters that are next to each other. The first one is the slope. The letter that's all by itself, that's the one that's not the slope. That's the y-intercept. Okay, so the a is by itself, and the b is by itself. Anyway, we're going to make it in this form because this is what Desmos understands right now. So how do we do that? We put in this y, now y sub 1. And the way I did that was I just simply typed y and then the number 1. It automatically knew that I wanted to look at list number 1. So I'm using the y values and I'm comparing them to the x values. So now instead of running an equal, I'm going to run the tilde symbol. The tilde symbol in Desmos is the regress upon symbol. It's telling me, what do you want me to regress these y values on? Well, I want to regress them on the x sub 1 list or the x list. And remember, this is going to find for me the value. Now, remember what I want, though. I want the slope also. So in front of the x value, I want to put m. Notice that I'm starting to get now, in the left-hand side, I'm getting a parameter, and that parameter is my slope. Okay, well, what else do I need besides that? I need a plus sign, and I need a b. I'm going to do all that over again one more time, all in order for us. And notice I got a nice, cool looking line right there. So there you go. Ready? y1, we're going to regress upon. We have the regression. We need to put the slope in. We're going to regress upon x1, and we're going to add a y-intercept, which is known as a b-value. Over here on the left-hand side is some incredibly important data for you. Your r value that I'm going to be asking you for is right here. R equals 0.9906 as we go through the course, and as you know, that will be a wonderful R value. What that's telling me is it's a super strong positive correlation between Y1 and M1. I can see right here that my slope is 4.25 and B value of negative 157. That means that in this data, this was cricket chirps and seconds is what this was. So we were estimating cricket chirps based on temperature outside is what it was. So we have a nice strong correlation between those two. And I have a rise of 4.25 approximately for every 1 degree of temperature rise. My B value doesn't make sense because it's a negative 157. For two reasons it doesn't make sense. One, it's negative, and I don't believe we're going to have negative cricket chirps. And two, we would not have a data point so far removed as this one because the y-axis is all the way back here. Also, another key factor here, I want to show you. I'm on the y-axis right here. If I just simply hover with Desmos and I click and I hold right there, notice I can get the y-axis intercept just by clicking that value. I'll do that again up here on the x-axis. If I want the x-axis intercept, I just simply hover by it. I click and see it turns gray right there. I click that gray value, and that's the x-intercept. If I want to get back to the nice looking picture here, remember, I go back here, and it takes me right back to the nice picture. All right, so I have a couple of things here. One, I can write my equation, and I'm going to write my equation without Desmos. Y equals. Now I'm going to put it in the form of ABX, if you remember right. In ABX, we did the y-intercept first, which was negative 157.8 plus, it was a slope next. I can see the slope is 4.25. And you always have to have an x value on there, and you can see mine just turned green. I'm going to hide this blue one so it's gone, and you'll see that my green one right there is the same exact line as that blue one, because if I hide my green one, there it is. And I can also change the color of my green one to maybe dots or something like that. Let's do dots right here. Let's do this one. And we'll make it orange. There you go. So you can see it laying down on top of the blue one, where the blue one is underneath of there. They are the exact same line. So we're using our regression in order to find a couple things. I also said that not only would I do that, I would regress for you and show you the regression plot, the residuals. These residuals are really good. And how do I know they're really good? Because the R value is really smoking good. 0.99 is awesome. But if I plot my residuals right here, when we have a good line of fit, our residuals will plot themselves in such a way that one, they don't form a pattern, and two, they're very close to being basically zero on the y values of up and down. The distance that this dot or this data point is from this line is the distance of this dot from the x-axis. And this one, super close. See how super close it is? This one's below. If a residual is plotted below, that means it's below the data point. And if a residual is above, it's above the data point. And the closer it is to being horizontal, the better it is. This is a very nice fit. I'll show you some later that aren't such nice fits, and you'll see data points all over the place when we graph the residuals. That'll be all for this one. When you come back, we'll be doing some more Desmos.